Thanks for having me here. My name is Alex Berger. I'm a principal engineer working on our cloud managed portfolio. And joining me is Stephen Orr, distinguished engineer. And we're here today to talk about Meraki Access Manager, which is kind of our cloud native zero trust service that we just launched this week. And I want to get into a little bit of detail there. Well, I got to turn on my clicker. There we go. So yeah, just going to go through a quick level set intro, get into Access Manager and the cloud architecture, and then hand it over to Mr. Orr to do some use case walkthroughs and then a demo. So for those of you that aren't familiar, and I think everyone here is familiar with Meraki, but anyone watching that's not familiar with Meraki, Meraki is Cisco's cloud managed network platform. And within Meraki, we've always had support for .1x services, whether it's simple things like VLAN assignment or access lists attached to a radius session, or even like zero trust with micro-segmentation using adaptive policy. But we've always relied on an external radius service, whether it's Cisco ICE built out and self-hosted, or even cloud services. And with that, you have a lot of complexity when it comes to connectivity. One of my least favorite things is trying to figure out how to build different types of tunnels to secure communication over the internet so that you don't send credentials in clear text, because radius itself is not very protected. And there's a lot of cost associated with hosting things yourself. And like could be from maintenance, monitoring and management, and then also paying for the power and everything that comes along with hosting your own services. And then there's also having to manage overlays for connectivity and being able to make sure that network devices can still communicate with those core services, because if radius is down, a lot of times the network isn't necessarily operational for users. And so not only that, but all of these things come with a consistent need to sync policy configurations from your network devices to that security appliance or security service. This means things like access list names, SGTs, VLANs, and what VLANs are appropriate for a specific implementation. And so there's a lot of console pivots, which can be kind of difficult, especially if you're just getting in and you're having to train people. They have to learn the network UX, security appliance UX, and then have to understand how to troubleshoot all those and jump between the two pretty consistently. And so we took a lot of feedback from our customers over the years, and we've had a lot of folks ask us, hey, how can I get a cloud managed service that kind of takes care of a lot of that pain and a lot of that extra effort when it comes to just wanting to deploy secure access to the network? And so we built Meraki Access Manager as a scalable as a service solution in our dashboard, so you have a single console. And we support wireless and switching today for .1x and MacAuth so that we can authenticate the devices that connect and make it very easy to apply things like SGTs or group policy assignment, and keeping that context in dashboard. So when you go to build a rule, you don't have to go and look up what the name of these things are. We have all that stuff populated, so you can just drop down and select it.
I have a question.
Yes.
Does it also work with non-Meraki switches?
Not today. So when I say Meraki, and I'll go into what we specifically support, but it's anything that's Meraki managed. So that could be Catalyst or our MSs today. But some of our key focuses from feedback we received from customers was to try to help reduce management overhead. Not everybody likes to host services, and a lot of folks are trying to get away from having services that are they have to sit there and upgrade and take care of. So just trying to make sure it is as simple as possible. Keep everything within the same console, the same dashboard, so that when you troubleshoot, you can go from looking at an authentication or an authentication failure to finding where that device was connecting and getting any context necessary quickly. And probably the one that is nearest and dearest to my heart is helping enable adoption of micro-segmentation. So I've been working on Meraki's adaptive policy for 6 years now, and being able to have everything built through the same dashboard, not requiring extra services, makes it a lot simpler to actually get things going and take advantage of those services. Now, I mentioned earlier about credential transport, and whether you're building VPN tunnels or you're using like RadSec, usually you have to do extra work just to get stuff where you need it in a secure manner. But with with Access Manager, everything goes over the security tunnel that we use for control. So you don't have to worry about poking any extra holes in your firewall. It just rides over that same secure tunnel. That means if you have dashboard connectivity, you have access to, or connectivity to Access Manager. From a switching support perspective, as I was mentioning, all current generation MS, anything that can run MS16 firmware and above is supported. Our first generation of Catalyst switch management, which I presented on a couple times here, but is supported, and we're bringing support for our cloud native XE next-gen software stack that we just launched into beta. And hopefully here in 17.15.3, if that everything works out the way we want. From a switching perspective, we support EAP-TLS, EAP-TLS PAP for username and password authentication, and MAC auth bypass. So, if you have devices that don't have a supplicant, you can still do some sort of, at least, checking before they connect to the network. Over that tunnel, we do send, the credential exchange. We also send connectivity details through accounting. So there's profiling attributes, counters, et cetera, so that we're able to tell if a session's still active, and also start to pool a lot of that data together for us to provide granular profiling of endpoints. And from an authorization result, fairly straightforward, SGT, ACL, VLAN assignment. We're going to be supporting switch port templates or interface templates so that you could also automate configuration just by, you could do MAC auth and still automate the port config, or have full .1x, making sure that your network's locked down, but you still get a lot of that automation and capability.
I have a question for the profiling on the feature set. Let's say I have a print server that is in MAC bypass.
Mm-hmm.
Somebody unplugs this, types the MAC in, and starts then to doing some other, let's say, behavior than a normal print server would do. Would you be able to protect and say, okay, this is out of the profile, we should maybe start blocking this port because it looks like no longer the print servers here behind this?
Yeah, it's a great question. So we're working towards supporting a lot of the extra kind of attributes that we could use to determine, device has changed. Whether it's, following the profiling data, looking at like DHCP attributes, those different bits. If you've ever heard of device sensor, we're using the same concept for, in this case, but we don't have that set today. We are working towards it, and I have a slide towards the end of this entire session kind of talking about some of the stuff we're working on. We are looking at ways of taking like flow telemetry and figuring out if using that to help fingerprint. So like we have a lot of plans right now. It's just pretty much just MAC auth and then traditional authorization like through certificates.
The problem, the weakest piece in the whole thing, most of these devices have the MAC printed out somewhere on it, and kind of, you're only as good as the weakest point.
Absolutely. Yeah, and so we definitely don't like say use MAC auth and you're good to go. It's just an option. It does give you some automation, but yes, we do need to have more things to help ensure that people aren't spoofing MAC addresses. From a wireless perspective, just jumping forward, and if there's any questions, please interrupt me. But from a wireless perspective, anything that we've been shipping for the last 7-8 years is supported. So that's our 802.11 AC Wave 2 or Wi-Fi 5 Wave 2 access points and above. And all of those can run the R30.6 firmware. So if you look in dashboard and you're wondering what firmware, that's just the firmware indicator to be able to be supported. Wireless, same set of credentials, same kind of concepts. We're using sending the same kind of data, including those profiling attributes. And one big difference is obviously wireless uses PSKs in some cases. So if you don't have the ability to do .1x on your devices, you can still do per device PSK and then send back different attributes as they connect. So this kind of gives us a little bit of flexibility. So I want to get to the demo, or let Mr. Orr get to the demo. So I'm going to go through real quick on the architecture side and then hand it over to him. We look at high availability from a couple different perspectives. So there's the device side. All of our network devices build a primary and secondary tunnel, and those are two tunnel servers that are in geographically dispersed locations, so they're not sitting in the same data center. making sure that we have high availability for connectivity to dashboard itself. These are always in geo, so we're not going to connect you to, like, if you were in Europe, connect you to the US, it's going to be within the same geo. So not, so that we don't end up with any of the data privacy normal things that you have to deal with. But that means that, from a tunnel connectivity perspective to the cloud, high availability there from the device. .1x, MacAuth, any of those processes that we run locally, there are resiliency functions that we built in. We did just release radius caching on the Catalyst side so that if you had, a link severed, we can restore the last authorization. It's kind of one of those, you give up a little bit of the security side to keep the same policy in place, but so radius down, be able to restore that, that last policy. And there's other things like critical auth. Wireless actually has a couple fallback mechanisms to validating like certificates, and it is also building radius caching as well, so that we have a way of staying resilient across the board. Cloud service-wise, we are using Kubernetes and service clustering. This allows us to do horizontal scaling really quickly and to be able to support many sessions concurrently. Once again, from that tunnel termination, the services are available behind those tunnel endpoints, so there's no like rerouting and adding in tons of latency. But also with things like Entra ID, which is our primary IDP that we support today, or our main IDP we support today, we do synchronize any of the information so that we're not sitting there making calls to Entra ID over and over again for authentications, and are able to have it as low latency as possible. So trying to keep low latency, high availability. That being said, any questions before I?
What is the overall requirement that you have from a location to the back end when it comes to latency? How much is supported? So I'm thinking about some regions of the world where maybe the next cloud data center from Cisco is not that good from a latency perspective.
Yeah, and we do have really fairly dispersed locations from like latency perspective. Typically we see under 100 milliseconds of connectivity. We don't necessarily have like a latency restriction other than at some point endpoints or devices connecting. If you're performing like .1x, they may have some issues with not getting responses back in time. I don't have that right in front of me though on specific timers, but I think it does vary by device.
At the end of the day, will work, just the client has to wait a little bit longer.
Correct. It should, yeah. I mean, it's going to follow some of the standard radius timeout kind of concepts, but it's not multiple seconds, right? So it's
the ICE word, often there was extra tuning needed to make it work and so on, but you tested it for more or less all the regions and that was working fine, yeah.
Yeah, I mean, and I think as we just launched this, we're going to be continuing to build more and more things, and there probably will be things that we end up tuning as we go, but for the most part, yeah, there shouldn't be anything like hard line cut in the sand. That makes sense.
Thanks, Alex.
Yep.
Again, thanks everybody. Name's Steve Orr. So we're going to go through a couple of use cases. So again, would appreciate some feedback, and definitely on the latency issues with the 100 millisecond, kind of looking around that 100 milliseconds. That's really what we target. So I'm a Wi-Fi guy, right? So it's what we target for roaming anyway, right? So that's why Alex had mentioned about caching the credentials. So in case we're decreasing the need for those really low latency links by bringing some of the credential caching back down to the dashboard. So again, if there's any questions, please feel free. So one of the big use cases that we've seen, again, this isn't necessarily just for Access Manager. This is where we've been seeing things for micro-segmentation, macro-segmentation, with that convergence of IT and OT within the same infrastructure. So one of the things that we've seen, obviously everybody's familiar with, for us, it's called iPSK or PPSK or any of the wireless mechanisms. I like to call them vanity passphrases, because that's about what they're worth, is a vanity passphrase. But so we've got a couple ways to do it, right? So the IoT device could be an Xbox in a university. It could be an IoT device on a factory floor. They get on the network, they're going to authenticate. And what we're going to do, and as Alex had mentioned, right? So one of the things that Access Manager is really great at is accelerating the capabilities for adaptive policy in that micro-segmentation deployment. So I'm sorry, go ahead.
So it's a kind of a SGT, right?
SGTs, absolutely, yeah. So the scale, you'll see either secure group tags or scalable group tags. Have been around a while, so we've modified the name here and there, but yeah, it's secure group tags. So we basically, you know, we're putting a shim, the metadata field, with an actual value based on, you know, however we want to profile the device. So, and that's where you look at where it says the IoT group. So that IoT group is a logical entity that says, hey, this is this group tag that's defining that. Now, the good thing about group tags is we're actually shimming it in the Ethernet frame as opposed to relying on an IP address or something else. So it is immutable in the sense that the station doesn't set it. It comes in from the first hop network device, whether it's an access point or a switch. It imposes the tag, and that tag traverses the network, and we can do policing actions based on it. Again, so we can look up rules, which is the key thing, right? And rules could be anything. It could be as simple as SGT1 can't talk to SGT2, or you can actually get in and do some really fine granular ACLs also if you want to permit or deny specific protocols. So that's all within the realm of possible. That policy gets pushed to the network device. So the network device, as opposed to the client, is imposing the rule. And then we're using the infrastructure as an enforcement point, as opposed to a single point on the network. So again, when we abstract this out, we try to keep it very simple in certain cases where it's like, okay, I've got this IoT environment, so I'm going to be able to talk to a controller. In most IoT environments, you need layer 2 adjacency, right, to an IoT controller. But what we don't want it to talk to is other controllers. That's the key piece, right? And we definitely don't usually want the IoT devices talking to endpoint user devices, right? So then we get, say, door locks. Now, I've seen networks where they want to put, say, like a university, they want to put door locks and video cameras on the same network, but they don't want door locks and video cameras to be able to exchange information and talk to each other. So in this case, we can actually mix wired and wireless, even if it's the same VLAN, even if it's the same subnet, we can actually mix policies because the SGT is imposed at the MAC layer. So the IP addresses, I won't say they become irrelevant, but they don't become the major enforcement point, right? So it allows us to micro-segment within a VLAN within a subnet. And I'll show you a little bit later in the demo on some of the cool things we were able to do with bringing Access Manager out. But again, we just profile it basically on the way it gets on the network, and then we can dump it into the IoT building group. And then that policy matrix that gets defined is what enforces the micro-segmentation rules. Any questions? Go ahead. No, shoot.
Everything is set up because IoT devices became more vulnerable, right?
Yeah.
That's why you do segmentation.
Yeah. So, well, there's a couple things, right? So the micro-segment or the IoT devices depend on a couple things, right? So they like to broadcast. They like to have layer 2 adjacency. So typically what it means, say in a wireless world, it means I suddenly have to generate multiple SSIDs to handle the broadcast traffic. This way, it's almost as if the SSID just becomes a logical container, and we can use the SGTs as a way to segment out so that the your door locks won't see the broadcast traffic from the the IoT and for the HVAC controls.
In most cases, you don't have one IoT type, you have
Correct.
many, and you want to separate them. And
you can do it right. As I said, this is the kind of the OT segmentation. Like I come from the federal background, so we used to build parallel networks for everything. Very costly, very expensive. And it's the same thing in the OT world today, right? IT, OT, completely separate. One of the things that we're seeing people migrate to is being able to use like group tags to be able to provide that segmentation, that logical segmentation on the same physical infrastructure.
the dark downside on the other hand is sometimes they build an OT network and they dump all kinds of function into that, and then you have kind of the same problems that you had before. So
it's not a panacea for every potential problem, but for those OT networks that we can get to conversions on, it's a great way to provide that single physical infrastructure for multiple logical environments. Question? Good?
Yeah.
Okay, sorry. All right. So there we go. Yeah, so with the policy, right? So we can actually institute the policy for the building device. Again, like I said, could be door locks, could be video cameras, what have you. And then I really wish it was more complicated in this. It's really kind of point and click. It's like, here's this group, here's that group, permit, deny. Or if I want to become more granular and do a custom ACL, it's just that simple. So we're really providing this logical matrix versus coming from the world that we all came from. It's like, I've got to know the IP addresses, got to know the port numbers, got to figure out what protocols to be able to permit and deny. It becomes very complicated, right? Those access lists can become very unmanageable. So IT/OT use cases. So moving on, so another use case that we get involved in is managed devices, right? So I've got corporate managed devices, like, so at Cisco, our iPhones, our MacBooks are all corporate managed. So we use an MDM to push certificates. So that's primarily how we get on the network. So we do ETLS as a certificate validation, or you could do ETLS, whatever you want to do with an inner method for certificate-based. So, and everybody knows there's challenges doing certificate-based authentication, but what we're trying to do here is provide that operational simplification so you don't have that heavy lift for doing ETLS that you normally would. So again, we can do certificate validation in a couple ways. Alex had mentioned we have an IDP integration with Entra. We also have an integration with Meraki Systems Manager, which is integrated that you can use certificates from. So we have a couple different ways depending upon the scale that you need for your organization to do certificates. But very much the same way. You get on the network, you do an EAP authentication with, use TLS as the outer, negotiate with the certificates, you get an access acceptance, you're on the network. So the other one that we've seen, and there's a lot of work being done here, I'll call them, semi-managed IoT devices, where now that most devices are starting to ship with SUDIs, the secure unique device identifiers, customers are wanting to use the SUDIs to actually authenticate the devices onto the network. So there's some interesting things, like where you eventually see this going is like your light bulb, you screw in your light bulb, it powers on, and you're using instead of a MAC address, you're using the SUDI on the device to actually provide the authentication mechanism to prove that it should be on the network. So we're starting to see this. So again, those don't necessarily have great user interfaces. You're typically kind of vicariously going through an app or something to be able to put them on the network. So the fact that we can actually be able to use the network to kind of profile and then provide that segmentation is a huge benefit that allows us to create these simple rules, because then I don't have to know specifically, is it X vendor's IoT device or Y vendor's IoT device. It's all these IoT devices I'm going to put into an SGT. But again, same thing, mix and match your rule sets, kind of plug and play as you move along. Finally, I guess, as Alex had mentioned, the Entra ID integration that we do. So now, got a larger organization, we've got Entra ID, I've got multiple groups of users, multiple device types that are out there. How do I make this scalable? And again, apply the Meraki model of operational simplification to being able to manage an IDP and get those devices into the network. So one thing Alex had mentioned is, and I'll show you in the demo in a couple shots, we actually do sync the Entra ID database to the Meraki dashboard, so we can pull in the users, pull in the groups, so that we can actually use those to define the rule sets and the policies. Go ahead, you got a question?
Yes.
Go ahead.
It's called client misbehave.
What if a client misbehaves?
Yes.
So this is the ultimate challenge we have, period, right? Is what happens with misbehaving clients.
That's .1x. That's in the millisecond world instead of the second world of Microsoft.
Yeah. So if what you're saying is, if I understand your question correctly, what happens if a client, a supplicant, doesn't authenticate correctly?
And it starts a new one and a new one.
And it starts a new one. So I have a beautiful example of this, and my daughter will hate me because Alex and I just did this before the session. So the demo's running on my home network, so I'll get a chance to see my home network. But one of my MacBooks, which we're running ETLS on, misbehaved. So we had to use the tools that we had. I live in New York, so we were troubleshooting why this ETLS client on my MacBook was misbehaving. So we used a bunch of different tools, the logs that come up in Access Manager, and then it triggered, as Minse had just showed you, it triggered the intelligent packet capture. So we're actually able to pull the intelligent packet capture and see the EAP messages go back and forth, and realize that we had to go in and re-accept the certificate for ETLS. It wasn't, it errored out, so my daughter had to go in and click the right things to get the certificates back online. So yes, we can get notified. The intelligent packet capture actually does a phenomenal job in helping us troubleshoot remotely the EAP authentication. So we can get fairly granular, fairly deep pretty quick.
Just on the Entra ID that I got, what you can do, I authenticate against Entra, and you can assign me a group based on this membership. So now something changed. I log out, somebody else is logging in. Can you then reevaluate and assign a new policy, or how is this working?
Yeah, so it depends on how you're authenticating in. So if you're doing ETLS and you're doing machine authentication, right? So basically installing the, then you're based on not the user login, you're based on the machine login. So that's kind of a different scenario. Now, ETLS doesn't inherently allow you to do multi-auth, meaning I authenticate the device and the user. There's other protocols like EAP-FAST used to do it, TEAP does it, where you want to be able to have multiple EAP chaining is basically what we're talking about, right? I authenticate the device, I put it in a VLAN, put it in an SGT, then I authenticate the user and I can move it. That's like the functions of ETLS today, and TTLS aren't there yet.
Yeah, I see the industry is a bit shifting. We all want zero trust approach, yeah, and this is following the user. Everything becomes user centric and Entra ID centric, and we would like kind of in the future to see everything covered so that we somehow have a re-evaluation, that it is not one time I got access to the network, now I'm in, so that when this condition is changing following the conditional access approach, also my policies are changing with.
Right. So one of the things you can, like we've seen it in ICE and we've seen those, right? You basically tweak the authentication timers or the association timers in the wireless network to trigger that. So if the device falls asleep, it'll off in the back end.
You're talking about more like application access control, those types of things.
Yeah.
So I would say one thing we're trying to do is look at this as a kind of a east-west network kind of segmentation, the ability to apply those policies, but we still have things like SSE where you'd be able to, yeah, that X is really dark, I couldn't see it. But use things like SSE to be able to do that application enforcement where it could follow things a little bit more closely with the user and the access to the resources. You don't have to have that, but if you do need to get down to that granularity, that's a way to kind of combine the two.
Yeah, I understand where we are standing now. Just saying from my wishes as a customer, this is where I see everything is going: zero trust, identity-based, no longer machine-based. So I think machine-based is a thing that will fade out over time and everything will become more identity-based.
No, absolutely agree. And that's our struggle with certs, right? So you put the cert on the device. If the user logs out, then you're hoping that they didn't approve that cert in the trust store for every user on the device, right? Because then they're basically using your username or your credentials to get on. So there's work being done now to do some interesting credential work in both the IETF, IEEE, and Wi-Fi Alliance. So we'll start to see things develop a little bit more. Again, with Entra ID, kind of getting back to that similar topic. So this allows us to logically separate out the network. So I can have multiple EAP types on the same SSID, on the same wireless infrastructure, assign them to different, could be the same VLAN, could be the same subnet, and then do this with group tags. Or I could actually, as Alex has said, we could push the VLAN information to the access point, to the switch, subnet, and then also do group tags as well. So we can do this all based on how they come into the network or come on, and then if they switch SSIDs. So, and again, Alex had mentioned this too. So the important thing is the initial authentication goes back to Entra, and then what we do is we cache it so that we cut down on that latency time for having to hit Entra every time we want to do some type of an authentication. Because the big thing is the more users you have going to Entra, right, doing that authentication, that database gets really huge. So we're pulling in those users that are actually actively authenticating onto the network. And as I said, policy, same thing that we showed in the IoT example, right? Same kind of mix and match. I picked the SGT group, permit, deny, who else I wanted to talk to, or just give it internet access. All can be done just a couple simple clicks. And as we mentioned before, so we do EAP-TLS, we do EAP-TTLS with PAT, and then you can do MAC address bypass. And you can also do iPSK. So I'll show you an example of iPSK. Like it's always been kind of, I'll call it challenging to configure iPSK. And this way, again, we really do make the SSIDs become logical containers, where the PSK we no longer assign to the SSID. We're just basically telling the access point, go to Access Manager to get the PSK for this SSID. And that could be based off of, we can do things off of MAC addresses, or just, hey, if you have the PSK, you're going to get the assignment. So, so on to the demo. So before we jump in, are there any questions? I just have to switch my, go ahead, shoot, I'm going to switch and
So suppose I have some fiber connections in between my Meraki fabric. Is there a way to do SXP speaker and listening from Meraki sides to a firewall where my network is converging?
So I would give you the short answer. Alex is going to give you the much longer answer.
Not yet.
Okay, so not yet. No, we are looking at ways to more or less leverage SXP or things like that. The one thing we have to worry about is like scaling. So if you sync SXP in the wrong direction, you could blow up a switch. So we're trying to make we're doing some things hopefully to make it as foolproof as possible. But yeah, to be able to take situations like that. Yes, that was longer than I think you'd have said.
See, I would have said not right now. But so we can level set on the demo as well. So one of the cool things that we did when we set the demo up, Alex had mentioned that all of our cloud native Catalyst devices are going to be getting this capability. So every switch, every access point is running the cloud native beta code. So this is actually Cisco iOS XE on the Meraki dashboard using SGTs with Access Manager. So this is kind of the latest and greatest stuff. I'm going to switch to a chair so I can drive this for everybody so I'm not hunched over. And if you have any questions, please shoot. So what I wanted to share was this is kind of the corporate IoT SSID where we typically have identity PSK where you're trying to group devices. This is the bulk of the configuration. It's like one click. You put the identity PSK with radius, point it to Access Manager, and that's it for the SSID. There's no complex configuration. You pick your, obviously WPA2 personal and move on. Now, what I do typically is I don't leave it I put it in the default SSID. So if you scroll down, it's like, hey, what's my VLAN tag? I'm going to put it in a default dead end VLAN so that if you fall through the policy, I'm not going to allow you on the network with an iPSK. This way, you dead end. If you have the right iPSK, we'll put you in the right VLAN, we'll put you in the right group tag. So that's actually a real quick kind of down and dirty way of getting that configured. And as you can see in the left-hand side now, in the pane, we have an Access Manager. And can everybody see? Do I need to make it bigger? Good. We have an Access Manager panel here. So what we can do is, we'll look at users first, and I'll show you how easy it is to sync to Entra. So if you want to add your IDP, all we have to do in this case, you can see a quick summary of the number of users we have and the number of groups that we have. But in order to add Entra ID, you just go in and click, and you can add it fairly quickly, right? You just put your tenant ID, the application ID, value, and it'll sync and pull in the information. So again, much simpler, much quicker than we normally would have with trying to manage this across multiple servers. And then you can actually come in here, and as I said, we sync the users and their groups. So now we actually have usernames, where they're coming from, the IDP, and we have the user groups. All of these are attributes we can now use for authentication, wired or wireless, onto the network. And again, with that, we can also apply them into different SGTs. So, and we don't really bring the user information that we're bringing over, like if you click on them, it's just basically going to bring you kind of what groups they belong to, if they're able to belong to multiple groups. So let me move on here real quick, since I know we've got some time. So you can also bring in certificates, as I said. So we can bring in certificates from System Manager, bring them in from Entra ID, and use those for both. So when we use them for EAP-TLS, obviously there's one on the client, one on the server. With EAP-TLS, it's on the server, right? Because we're validating the server cert for EAP-TLS, and 99.9% of the time, we're giving an anonymous identity for that outer tunnel so that we protect that user's information. So let me go real quick, and I'll show you like the next step that I used to do this was I go to adaptive policy. Now, again, we've consolidated all of this under Access Manager to make it easy to use. So this is the foundation of the rule set. Basically, what we're doing is creating a group name. All right, you can call it whatever you like. Test. You can create an SGT value, 700, and then you put your description, and you can review the changes, and you click, and it pushes it to the infrastructure. Now, what we want to do from here, though, is this is already set up that we have on some of the user groups. What we want to do from here is go create policies. That's really the important part. And this is the simplicity of the Meraki interface on creating these, what used to be complex access control lists. It gives us the ability really quickly if we want to, I'll take a corporate IoT example. And what we've done here is we can actually go up and add a policy, and you see all your SGTs that are available. You can click on one and you can see what's blocked in red is already in use. That's already blocked. So what we can do is say, okay, I don't want my corporate IoT to talk to guest. And then what do I want to do? Allow, deny, or do a custom. The custom is an ACL. If you want to put in a custom IP-based ACL, absolutely can do it. But if you want to just say, hey, SGT, 500 can't talk to SGT 700. I just did a deny.
Destination ports.
So because it's in the MAC, it's a metadata field in the MAC. It's everything. It is not a. Now, if you want to do specific ports, that's when you go in and do the custom ACL.
Yeah,
so you do
custom ACL. I can do a port.
Yeah, you can do yes.
So I could, for example, block CIFS in my client workspace to prevent ransomware attacks.
Yeah, you can anything that you can do in a traditional IP ACL, you can put in there as well. Right. So what you'd want to do if you're going to default deny, then you're going to want to put in an ACL above it that permits the specific traffic that you're looking for. So again, like I said, I wish the demo was more involved in what it is to show you how to do these the permitting and denying of these group tags. But the policies basically immediately get applied into the infrastructure. So the next step to that is, okay, well, what happens from there, right? So if I go back to Access Manager, right? So now we've created the policy. Well, we've created the tags, created the policy, created the network that it's going to be on. So obviously we're not going to do it here, but we've got clients running in the network. So that was my daughter's work this morning to help us out. What we can show is the session log. So this is where you would go to see basically radius.
You want to show the rules, rule configuration?
Yeah, I just wanted to get to the authentication and get to the rule.
Got it.
So right from here, you can actually see, I'll do the last hour. You can see authentications. It'll list all the authentications in there, right? So you've got, in this case, IoT HVAC, I'm using as iPSK. We've got ETTLS coming in from one station. On corporate BYOD is an SSID, and then we've got another ETLS station coming in. So if you click on them, you get a pop-up window, and you get immediate information on what type of device. The cool thing that you can see right from here is what SSID, what VLAN, what adaptive policy SGT it's getting assigned. And then if it was a failure, you would get some additional information in here on where you needed to go to troubleshoot. So, and because it's certificate based on this one, we can actually see information on like the TLS cipher suites that were used. So there's some additional information there for those. So back to what Alex was saying, if we go back to the access rules themselves. Hold, please. So this is actually how we get the authentication done, right? So if I go create a rule, right, it's a linear rule. So you've got to, as with anything, right, you've got to make sure that you don't block something first that you want to permit. So in this case, I created a rule on corporate managed devices. This is one that was using an MDM. So the first attribute that we used was simply just using Entra ID as the data source, the IDP source. And then what you can do is you can actually go in, because we're importing all the Entra ID information, it auto-populates the list of groups. So if I want to match multiple groups, I can match multiple groups. And then, again, this was
just a side question.
Yeah.
If somebody's editing this in Entra ID, how fast does it sync until a new group shows up here?
So you can do two things. One, there's a default time. Do you remember what the default sync is?
I don't off the top of my head.
It's on the, I'll get back, but you can also, if you know somebody's edit, go ahead, Kevin. 4 minutes? 4 hours, okay.
Wow.
But you can actually go back in and there's a sync, manual sync. It'll trigger, so if you know somebody's editing Entra or adding new user groups, you can go in and do a manual.
So you're doing skim provisioning, I assume, or something like that?
I believe, Kevin, do you know specifically how we're doing the provisioning?
We've got a regular polling and synchronization. We can trigger like a resync. So if there's new users provisioned or a change made in Entra, we can force that. But we're bringing the timer down, and we mean to make that configurable in the future anyway. Thanks for the question.
there. So let me quick jump back to the access rules. So like I said, in this case, the first one we're doing is ETLS based. So if we look at it, right, so we're using Entra, we're making sure the account's enabled, just to make sure no one with an invalid account is getting on. And then we can actually use an endpoint certificate. So in this case, we're using anything that contains ADP, which is the certificates that we issued to the device. And then this is the key part for us, which is you can allow full access, deny access, or do the restricted access. And in the restricted access case, this gives us the ability to assign it a VLAN, adaptive policy domain, identity PSK group policy. So it gives us the flexibility there. So in this case, we were just I just said, hey, I'm going to put it in a VLAN 300. I'm going to put in an adaptive policy group corporate manage, which we defined earlier. And once you save it, that's the first rule that's going to get authenticated. To show you the other one, this was the identity PSK one, where basically come in, the actual first attribute is the network access. So we're basically saying it's coming in on a specific SSID. And you can click and pull down, do the drop down on the SSID. Restricted access, again, give it the VLAN, give it the SGT, and this is where you actually type in the identity PSK. So you're not actually binding the identity PSK to the SSID like we usually would. We're actually binding it to the authentication rule in the policy. So any questions on that before we? Good? All right. So again, same thing for ETLS, similar kind of configuration. Now you can get more granular. I didn't want to get too far down in the weeds on these configurations, but you can actually, on the same SSID, you can apply different SGTs and policies between using ETLS, ETTLS, and based on your groups. So you can apply multiple group tags in that same SSID construct, even inside the same subnet. Now, one of the other interesting things that we can do by looking at the actual client devices as well, one of the big problems we typically have is random MAC addresses, specifically on Wi-Fi, people coming in with random MAC addresses. We can actually police on random MAC addresses and make policy decisions. So if you're coming in on BYOD and you have random and changing MAC addresses configured, we can actually assign you a different policy until you change your MAC address to something that's not random. So again, just some granular capabilities that are inside.
Is it also tied into Meraki Device Manager, so I can create an onboarding experience with a certificate push?
You can still, yeah, you can still use Meraki. We're not precluding you from using Meraki MDM to put a policy
together, so that a new user comes in, joins in on the open network, identifies itself using SAML and whatnot, and then pushes the certificate and a change of authorization to push it to the corporate SSID.
Yeah, there's no reason you can, I mean, from a certificate distribution or install, using an MDM is far better.
Does it tie in with Access Manager to create those kind of policies and flows?
So you would use Access Manager to identify, basically you have the cert in the cert store here. You would use Access Manager to reference the certificate that Systems Manager pushed down. So if I go back, sorry, I'm jumping around on this one. If I look at certificates, because this is my network and I have both Systems Manager and Entra configured on it, I do have the CA from Systems Manager configured. So you can actually have a mix of multiple IDPs. So in this case, I have one that I use for just authenticating against Systems Manager, and I can still apply policies to.
Yeah, and to your question, we have a thing called trusted access
No, you're good.
a thing called trusted access that can be used along with it so that you can provision BYOD devices, for instance, with TLS.
So what we can jump to is we'll jump in on kind of the intelligent packet capture piece, what we were talking about before, just going to show some of the capabilities. So as I said, Alex and I were downstairs trying to troubleshoot why we had an ETLS client failing, and the intelligent packet capture on the MR picked up that we had radius login failures. So again, you just click on the intelligent packet capture, and there's a bunch of different profiles that you can use. And one of the cases, you can pick on EAP, and it'll actually bring up the EAP types and just filter out the EAP types and highlight them so that you can come in. And what we basically found out that there was an alert down here that the client was getting disconnected, and that's when I called up and found out that the cert needed approval on the laptop. So definitely a massive time saver. And the same thing can be done from a group tag perspective. We're not doing group tags on this one right here, but you can pick on an adaptive policy filter, and it'll highlight and show you the adaptive policy interactions between the sources and destinations.
I'll go through a few of these, and then if you have any questions, anything, just let me know. So, is there more? I usually try to put something a little more cheeky in there, but that's what I came up with this time. So, as Stephen mentioned, we're working on bringing in all of the kind of cloud native XE supported switches. That's like 9200L. Here soon, like 9200s, we're going to be bringing in 9500s, which are probably less likely for .1x and these types of services. But as we bring in all these platforms, have support out of the box to be able to, perform authentications, authorizations with Access Manager. And I think I need to verify that it should be 17.15.3. We will put it in our release notes. So we'll put it in our release notes. So if you are looking at this later, you can check and see. We are building out a user database and dashboard. Not everybody wants, or has like the need for Entra ID. Some smaller organizations want to just have a user database they can manage themselves. See this a lot, especially, unless you have like hundreds and hundreds of users or thousands of users, a lot of times folks want to just build something quickly. This also means that you can have backup user accounts if you don't, like for, temporary users, like contractors that come in. But there will be a UI and an API-based management so that you can create accounts, manage accounts, however you'd like, whether as a human or as a script or whatever running. I mentioned this earlier, but we've been working on a lot of things to dynamically change interface configurations based on small things like you could match CDP, LLDP type data and automate a port. That's not necessarily secure in any way, shape, or form. So also using things like .1x or MAB to be able to change a port config. And an example of this is we have a feature called Secure Port, which is where our access points use certificates to actually authenticate and then get a trunk configuration so that they can pass traffic. We're bringing that into Access Manager so that we can have a little bit more control over what the interface configs are, but be able to make sure that if someone unplugs an AP, the port isn't open for the world to do whatever they'd like. And that's a big one. I'm actually looking forward to this because there's a lot of other things that we're looking to build out, trying to kind of create a way to secure, but have some of that automation for config.
Is this also addressing the use case of unmanaged switches? So often we have all these nice policing and somewhere somehow added an unmanaged switch and then they are sitting, everybody plugs into that unmanaged thing. So you could be able also to limit then, I don't know, via vendor MAC or see if you have multiple MAC addresses on such ports.
Yeah, you could. Going back before I get to that next one then. In that case, though, we could also use something like multi-auth, which is you can authenticate many devices behind a port. And that gives you the ability to still apply policy as that traffic ingresses. And so if it was like MAC auth or if you were doing like actual .1x, unmanaged switches are a pain. So it's just kind of trying to work around some of that. But that's a way I would probably do it, is probably using multi-auth and then just applying those policies directly. But you could use the port, like a port template, and essentially put it.
I'm security, I would shut it down. Yes.
Yeah.
But could I also use neat or something similar to neat, so that my switch is actually being authenticated in multi-domain as well to prevent misuse on the uplink?
Right. So definitely a goal. One of the things that's kind of scary about having the infrastructure authorized is there's any blip in like a network device doesn't connect. A lot of people will try it and then not necessarily use it through the whole architecture. So definitely want to do something like that. We, as I said, with the access points, we have the ability to authenticate them with a TLS certificate. That doesn't preclude us actually looking into like, switching.
Those kind of boxes.
Yeah, absolutely. And I mean, it's a good call. It's something we've been looking into. I'll just put it that way. But yeah. The other one, and this one's important. And Kevin that popped in here has been doing a lot of really good work on this profiling side of things. I mean, not everybody knows what's connected to their network or knows what types of devices. You have a really distributed environment, doing inventory and trying to track what's there is difficult. And so not only difficult, but also trying to identify what types of groupings you should create for policy. You could put everything in IoT, but as you mentioned earlier, you have lots of different IoT devices, and some of them are going to need different policies than others. And so we are building out, taking profiling attributes and doing really granular profiling, not only so that we can tell you what type of device it is, but also make suggestions or guided SGT creation, so that if we see very common device types, be able to group those and say, would you like to create an SGT based on that device grouping. I didn't put this on here, but we are also looking at pulling in flow telemetry and then giving you kind of a guided policy creation on top of it, so that you have two devices and you want to make sure that you're not dropping legitimate traffic, be able to look at historical communications and have a policy that that you know is not going to get you fired, I guess, is a best way to look at it.
Starts with the clients, right?
What's that?
It starts with the client. That's the most important part, to get them visible, how they behave. And
absolutely. And in the meantime, we do have support for things like we do flow telemetry exporting. So a lot of folks have flow analysis tools. Like Secure Network Analytics does actually this policy kind of visibility, so you can see the flows between groups. It's neat stuff. But yeah, we want to try to bring all of that to the cloud, so you don't have to have services that you have to manage yourself. Last thing, IDP expansion. Entra ID is just the start. This one's is kind of being worked on in parallel to bring in more and more cloud identity providers. I think the biggest thing is we want to try to keep it as simple as possible, same workflow, add a new IDP, pull in the accounts, and then be able to have the granular matching of users and groups, et cetera. But that sort of wraps it up. Any questions?
Any plans for other identity provider than Entra ID, Okta, or
Kevin?
Yes, the obvious ones be Google and Okta that we want to work on next. There's also some Cisco developments on this front too that we'll be working with. So all of the above, and the goal would be to make those IDP integrations relevant to other services in Meraki Dashboard too. So not just for our security use cases.
Any plans on integrating it with the MX series, so I can finally do group VPN based on SAML?
Integration with MX. So yes, things what we've delivered first is focused on managed switching and wireless. We also have other categories of devices, like switches that are only in a hybrid mode, monitoring, so there's other options to support, and multiple use cases for the MX, potentially including some additional authentication options as well as the ones we've outlined today.